Hi, welcome to AWS Innovate. My name is Craig, and I'm the head of Analytics, Big Data, and AI for AWS in Asia Pacific. We're really excited to have you here today. This is actually the 5th time that we're running Innovate, and the first time that we're running it on a global basis. So it's great to have you all joining us. Now, we've got a packed schedule through the day, and we hope it's really useful for you. But to kick things off, I first want to introduce Dr. Werner Vogels, and he's going to share with us around empowering builders and innovation accelerators. So with that, I'd like to hand to Dr. Vogels.
So at AWS, we've always thought about builders. Our customers are the ones who actually roll up their sleeves and start building their applications. And when you think about builders, maybe the best analogy to use is that of building a house. In the past, most platform vendors would give you a prefabricated condo. The one thing that you could do there is maybe repaint the walls or move the walls a bit, but in essence, everything of the house was already built for you. Basically, they were telling you how to build your house. At AWS, we always felt that the next generation of houses being built would be radically different and very unique for each of the different businesses that were building their house. So you need to have a whole toolbox of different tools and mechanisms that you can use to build a house exactly the way that you want to build it. So that's how we're looking at builders. Those that need individual tools to build exactly that the way that they want to build. Now in the past, this was clear that even though companies were saying that they were listening to their customers, in essence what they were saying, yes, Mr. and Mrs. Customer, we hear you, but we're the experts, we know best. At AWS, we believe that you're the experts. You know best how to build your applications. And that's why we give you a toolbox of more than 125 different services. So if you think about who are builders, it's not just developers. I think everyone today in the organization is part of the builder group. And whether that is developers or data professionals or data scientists, or even your CTO and your CEO are absolutely part of building sort of the next generation phase of your business. Now, if we look back to the past, probably if you're like me, you've gone through a few iterations of types of development, this is a picture that looks very familiar to you. It's a sort of the 3-tier architecture. Front end, web tier, middle tier in terms of applications, and you have a database tier. Now, in the early days, this really worked well because we were just building web apps. But then pretty quickly, each of those tiers became massive with additional functionality. And if you're like me, you've used the web server tier as an application load balancer or as a message router. Who hasn't used Apache and Nginx for things that had nothing to do with the web? The same goes for the application tier. All of these became massive monoliths with lots of functionality built in and very, very hard to scale. Now, if you look at sort of how the next generation development looks like, powered by cloud, it looks like this. Our friends at iRobot are building these Roombas, and all of those are internet connected. And what you see in the backend is that there are no servers anymore. There are no web servers, there are no application services. It's all a web of services provided by AWS, connected by Lambda functions written by the guys at iRobot. And as you can see, all the different functionality in their application, in the backend application, is all driven by individual serverless services by AWS, including serverless compute. And that's really how the future of development is looking like. Now, if development is going to change, we need to really make sure that the process of development is changing with that as well. The whole process of writing code, checking in, building, testing, and deploying, and then operating actually has many cycles in it as well. There's patching, there's updates to libraries, all these kind of things that you need to do. And then, of course, you have these cycles that are going in there because you're not continuously checking in and building and then deploying. What you need there, as every good platform has a great IDE. And in this case, we have AWS Cloud Line. It's an IDE that is fully cloud native, that allows you to build your applications exactly the way that you want to do in the cloud. And of course, it has support for all the different programming languages, but most importantly, it also has support for Lambda, native Lambda development support. It's the only IDE in this world that actually has that kind of support. Next to that, Cloud9 also has support for collaborative editing, meaning that if you do peer programming, it's easy for you to not even be in the same location, but still to collaborate on developing the code that you're building. Cloud9 is built on all of the CodeStar tools, so underneath there you have the rock-solid AWS tools that you can completely customize the whole development pipeline in the way that you exactly want to. And then, of course, at the end, we need to make sure that we have support for operations as well. And whether you deploy that into production or whether you stage that into earlier environment, you really need good operational tools. And as you can see, we have a whole collection of tools there so that you can exactly manage your systems the way that you want to. I want to call out one thing there, AWS X-Ray, if you haven't taken a look at it. If you build distributed systems the way that most applications are built today, you really need good, deep insight in how each of the different components is performing. It might be that you have some VMs connected to some containers and some serverless and connecting different databases into there. And often, tracking issues back to the real source of these of a problem is difficult. X-Ray gives you deep visualized insight into exactly how data is flowing through your system for the different components. So check it out if you're interested in that. So when we think about choice, the first and foremost thing to think about is choice in compute. And at AWS, you want to make sure that you have the right tools to build the application exactly the way that you want to. Whether you still want to use virtual machines, or whether you want to go to microservices using containers, or whether you want to ditch all of these servers completely and go serverless with AWS Lambda. If we look at virtual machines, their usage is well known. This is sort of the early days of cloud where we started off with virtual machines. And what you see is that large software packages still run inside these virtual machines. And in general, you run your virtual machines in a matter of days to months. And I've even had a customer recently that sent me an email that said that he had a 10-year anniversary of his virtual machine running. It's clear that updating to this virtual machine happens through patching instead of sort of completely rebooting or restarting the machines. Sure, we need to make sure that you actually have all the choice in the virtual machines that you need. There's a broad spectrum of compute instances available for you so that you can pick exactly the tool or the virtual machine that you need to get your job done. If you think about this, you no longer have to be afraid to make mistakes. Maybe in the past, when you had to spend millions of dollars on buying more hardware, you would be stuck with the hardware. But now, if you pick a compute-intensive instance, and it turns out that you're I/O constrained, it's easy for you to switch between these instances. So really make sure that you experiment with your software to find exactly that compute instance that matches your needs. Most of the software that was developed in these virtual machines looked like very monolithic, large pieces. And when you actually need to scale them, it's hard because you need to scale up all the software, not just the one component that requires scaling. By decomposing such monoliths into smaller building blocks that each have unique scaling and reliability and security requirements, you're able to build a much more flexible, more agile system with much faster development. And that's something that we call microservices today. And microservices is strongly supported by containers. And with containers, you always have choice. Whether you want to use Amazon ECS, the Elastic Container Service, or whether you want to use the Elastic Kubernetes Service, you have choice. And also, these days, we give you the ability to run your containers over Fargate, so that you no longer have to worry about exactly how to map your containers down onto virtual machines. We manage that infrastructure for you in a truly cloud-native fashion. If you think about containers, software patching is not happening. What you do there is you basically build immutable versions of your containers and then create a next version once you're actually ready to upgrade. The last pillar, and in my eyes one of the most important new ones, is that of serverless. If you think about sort of all the different services that we have at AWS, whether it's SNS or SQS or S3 or DynamoDB, all of them are serverless, meaning that you don't have to worry about exactly which AZ they're running in. You don't have to worry about in which servers they're running. You can just use their functionality. Now, the one thing that was missing there is to have the same ability in compute. so that you can just write your business logic, drop it somewhere, and AWS will take care of it where it needs to run, regardless of how it needs to scale up, how reliable it needs to be over multiple availability zones, and what kind of security parameters to set. Again, here you build your functions immutable. So updating happens through creating a new version. The financial consequences are very different though, where VMs and containers still run about the amount of capacity that you've allocated on a per time basis. In the case of serverless, you only pay for the actual execution time of your functions. Yeah, so we all want to just write business logic. We don't want to manage servers and things like that. We really want to be focused on only building those pieces that we really need. And it's not just compute, you know, whether you have your data pieces, your communications, your monitoring, development, all of these are serverless components that you can glue together by using AWS Lambda. And so the benefits of serverless are really important. You no longer have any service management, you have flexible scaling, you can go and run one function or you can run 50,000 in parallel. They automatically are replicated over multiple availability zones and you only pay for really that for what you've reused. One of the things that we've seen with our customers in serverless was very surprising because normally new technologies are first adopted by, let's say, younger technology style companies. But what we've seen is that enterprises are very quickly picking up serverless as their main infrastructure approach because they no longer have to manage servers and only have to pay for that capacity that they've actually used. So again, we give you choice here so that you have exactly the right tools to use, whether you want to use virtual machines, containers or serverless, or a combination of both. Because what we see with customers that run quite complex operations, for example, with an SAP ERP system in the background, they may run some VMs there, they may run some containers next to it, and then for all the new pieces that they're building, they're making use of serverless. So use the right tools from compute to meet exactly that, what you want to do. We've learned over time with millions of businesses running on AWS, exactly what are the best ways to build your applications. And we've collected this information into the WellArchitected Framework, and I urge you to check that out. It has 5 different pillars: operational excellence, security and compliance, reliability, performance, and cost management. In each of those, we give you advice about how to best build your applications. Most of these are triggered by a set of principles, such as no longer have to manage capacity up front and things like that. So there's a whole range of best practices advice that we give you in the WellArchitected Framework. I want to lift out one of them because I think it's increasingly important that we think about the security of our systems. Yeah, if we've looked about the past years, we've seen many new data breaches happening and very frequently. So it's important that all of us start thinking about how to build secure, protected applications. And we have a whole set of best practices there. Again, for example, take implementing a strong identity foundation. But also then using that identity foundation to, for example, implement least privilege. That is something that we do within AWS all the time. Basically, from our operational engineers, we take away their privileges until they can't do their job anymore, so that they really operate with least privilege in their environment. Yeah? An S3 engineer has no need for access to any of the EC2 instances, for example. And if you think about security compliance, it's becoming increasingly important, and definitely in a world where privacy and security are really on the forefront of everybody's mind. And with compliance systems such as GDPR coming out, it becomes even more on the forefront as everybody has to implement these. The thing is to think about in the current systems is that with all the continuous integration and continuous development that we like to do, old security mechanisms don't work anymore. Yeah, the development of 6 months after which the security code team comes in and reviews your 50,000 lines of code and then gives you a stamp of good housekeeping, that's no longer sufficient. These days, with continuous development and integration and deployment, security needs to be everyone's job. And one way to look at this is that you need to build a pipeline that actually has all the different steps in there, which you can then also get security requirements from. Automation plays a really important role there. We have a whole set of automated tools for you that you can use to continuously inspect your environment to look, for example, whether you're still in compliance with PCI or any of the other regulations that you have to be subject to. So protecting your customers and your critical business data should always be your number one priority. It definitely is that for AWS. It will be forever our number one investment area. And the most important tool you have there to protect your customers and your business is that of encryption. Encrypt everything in transit and in rest. Remember that 5 years ago, maybe 8 years ago, we were still having a discussion about that HTTPS will be too expensive. Now, every consumer service runs over HTTPS. And the same needs to happen for using encryption for storage and transactions. We integrate encryption into each and every one of the AWS services, so make use of that. And you can have us generate keys for you, or you can bring your own keys. With that, it means that you're the only one who decides who has access to your data and nobody else. A good example there is Redshift. In Redshift, each data block is encrypted with a random key. And then that set of random keys is encrypted with a master key. We can generate the master key for you, or you can bring your own key. In that particular case, you know that you're the only one who decides who has access to your data by managing your own keys. We've talked about empowering builders. Now let's take a look at sort of what are the innovation accelerators that AWS provides you. First and foremost, of course, there is the breadth and the depth of services. With well over 125 services today, and last year we launched 1,400 new main features and services. We continue to give you exactly those building blocks in your hands that you need to. And the days that it was just compute, storage, and databases are long gone. Probably that was 2009 that we saw that for the last time. Currently, we're offering services in IoT, in mobile development, in analytics, in machine learning, in deep learning, in vision, and in audio. All of these different services are available for you to build exactly in the way that you want to build your applications. One of the most important new features that we're seeing coming out, or the new services coming out, are around machine learning. Machine learning is something that most of us have been doing for the past 25 years already. Because when you think about analytics, there's sort of three different types of it. Yeah? One type of analytics is really that of looking towards the past. Yeah? Redshift, data warehousing, report generation, things like that. The second pillar is that of real time. Yeah? What is my inventory level right now? What are my customers saying on Twitter about me right now? Where you're interested in real time, using tools like Kinesis and EMR and Elasticsearch. And then there's the third pillar, is that of looking towards the future, making predictions. Well, we're really bad at making predictions. And so the best next thing that you can do to making predictions is actually take data from the past and use that to make an educated guess about the future. Now, that's what machine learning is all about. Now, if you've been using Amazon the retailer, for example, for the past, let's say, 20 years, you've been exposed to machine learning every time. And whether that is through recommendations or similarities or bestsellers, all of those are driven by machine learning. And recommendations probably is the best well-known machine learning service out there. Now, if you talk to the Netflix guys, they will tell you that 75% of the movies watched on Netflix are driven by recommendations. Basically, you go sit in front of your TV and ask Netflix to tell you what would be the best movie to watch right now. And we see recommendations coming back everywhere, even though they were pioneered by Amazon. And so if you look at machine learning in Pinterest, they use that to automatically classify imagery, to wheel out spam, and to add advertisement. And if you took a look at the reInvent keynote that I did last year, you saw a customer on stage called Heat. They work with the UFC, the Ultimate Fighter competition, to put sensors in the gloves of fighters. So they know exactly how hard you hit your opponent. And then you have cameras on their faces to really see that microsecond of pain that occurred in his veins and does automatic analysis on that. So people watching these fights will get all sorts of automated information, augmented information to enrich their experience. All of this is driven by machine learning. So machine learning at Amazon has a very long history. We've been doing this, of course, for the past 25 years, as I said, and it has driven a lot of innovation. Things like the drones and Alexa and the Amazon Go store, which is the cashierless checkout store. All of these are major innovations driven by machine learning. But what's most important is that there are actually thousands of applications of machine learning in Amazon that are not that well known. Demand forecasting, vendor lead time detection, fraud detection, predictive search, all of those are machine learning applications. And what we saw was that that in the beginning, machine learning was really the domain of data scientists and data experts. But when we started building services around this, we saw that every engineer could become a machine learning engineer. Actually, not necessarily developing new algorithms, but using those algorithms to implement systems that would make smart use of the data that we already have. So one of the challenges we had at Amazon.com with using machine learning was that it was really the domain of data scientists. And what we really wanted to make sure to get better use and smarter use of all the data that we have, that every engineer should be able to become a machine learning expert by building new services that would abstract away much of the heavy lifting that data scientists have to do. When we built those, we saw a true explosion of machine learning applications within Amazon, whether it's abusive review detection or fraudulent good detection or counterfeit good detection, all of these kind of things, all of these features are driven by machine learning within Amazon. So we have a lot of experience in actually building these, and we have literally thousands of engineers working on machine learning applications. Just like many of our customers. Tens of thousands of our customers are running machine learning on AWS. Now, with all of this knowledge, both from Amazon.com as well as from these tens of thousands of customers, we've come to realize that machine learning needs a new stack. Really needs to be able to dive deep into massive cloud scale, be able to extend it with all sorts of new algorithms, and basically make it accessible for everyone to use, not just data scientists. And if you think about machine learning, basically what you have data that comes into the cloud, then you use an algorithm to train it to create a model. And actually, in some sense, machine learning is pretty dumb, pretty brute. Because what happens is in the training phase, what you do is basically train again with every time with a different parameter until you get the accuracy that you are looking for. Now, if you then have created a model, we get a new data coming in, then can make a prediction. A good example of this is at Amazon.com, we literally sit in billions of orders. And we know exactly which of those orders were fraudulent and which ones were not. So you can create, using machine learning, a model there that then when a new order comes in, you give it a score what the likelihood is that this is also a fraudulent order. And then if that would be the case, you would actually hand it off to a human to investigate further. So that is really how it works. You have data, you push it through an algorithm to train, you create a model, and then you use that to make predictions about the future. At AWS, our mission is to make that machine learning can be in the hands of every developer and every data scientist. For that, you need a stack that actually serves exactly those constituencies. The frameworks, as well as the hardware, frameworks like Caffe and MXNet and TensorFlow needs to work really well on AWS with our deep learning AMI that can run on the P3 instances. Then for every developer that actually wants to use algorithms instead of create them themselves, we have SageMaker that helps you actually with all of the heavy lifting that you will see happening in machine learning. And then there's the whole group of developers that is not even interested in creating new models, that just wants to use a model. And so we have a whole series of pre-built models for you to use around image recognition, video recognition, text-to-speech, translation and transcribe of texts, comprehend, do sentiment analysis and entity extraction, and LEX, which is automatic speech recognition and natural language understanding. So if you want to learn more about machine learning on AWS, go to ml.aws and you'll find a wealth of information there, how to get started in any of the different tiers of the architectures that we offer. Whether you're a data scientist, whether you're a developer, or just an application developer, we give you support there for everything that you want to do. So let's now hand over back to Greg, who's going to talk to you about transformative innovation.
Thank you, Werner. So we just heard about empowering builders and innovation accelerators. So now let's talk about transformative innovation. There are really a few reasons why our customers make big investments in trying to be more innovative. And when we talk about innovation, there's even a group of customers that want to do more. They want to really transform their businesses. And it tends to be driven by three things. The first is around immersive experiences. And this is ways that businesses and organizations are providing these natural experiences for their customers, having better personalization and taking down some of the barriers of how people consume their products and services. The second is around creating better cultures of experimentation. Now, often this is tied to the use of machine learning and better empowering their data analyst and their data scientist. And the third is around net new business models. So within these business models, sometimes really transforming the business and launching totally new products and services that monetize that data and expertise that they've been building for years. So in order to really understand how they achieve this kind of transformation, we first need to look at the one common thread that connects them all, and that's having a modern data platform. So in order to be able to deliver these kind of transformative innovation experiences and capabilities, it's about this investment. So AWS Services have been used to build some of the largest, most resilient and secure data platforms in the world. Let's dive deeper a little bit and see how that happens. If we look in the traditional world, the way that businesses were able to achieve the analytics was they had a very large data warehouse. And on that data warehouse, they stored as much of the business data as they could, and they tend to be talking in terabytes, maybe up to petabytes in scale. Now, data warehouses are really good at solving some problems. They're good at answering dimensional queries. They're looking across time or across product categories, but they're not great at answering other kinds of questions that might involve sensor data or video data or other non-traditional data sources. So the data warehouse, although it's good for operational reporting, the business needs have somehow evolved. So let's look at what that extension looks like. The extension is often met by the use and the build of a data lake. And what a data lake offers is it's a way to not only take in that nice transactional dense data, but the ability to process non-traditional, more sparse data sets. Things like connected device data and looking at those video data and audio data sources, even pulling in social feeds. Now, not only are they pulling in much larger and non-traditional data, but they also need to do this in a way that is very cost efficient. So instead of storing everything in a very high-end data warehouse, they may also want to have a much cheaper way and cost-optimized way to store all of that data as it moves into terabytes and petabytes and even up to exabytes. So Amazon S3 is the preferred storage layer for building a data lake. And the reason why our customers choose S3 as the most popular choice for their data lakes is that we've been building S3 for a long time, Amazon's simple storage service. It has 11 nines of durability. It has built-in encryption, has audit capabilities. It has fine-grained controls for access. And what this means is that as customers want to store their most precious, those crown jewels of data, they're able to do it in a platform that's designed to scale and to be secure. But storage is not the only part of the story. So S3 may be the preferred storage layer. However, there's also a layer of management and governance that sits on top. So where before, if you had a single data warehouse or a single Hadoop cluster, that was okay because the data lived in one place. But now the data might be coming from many places and it looks quite different. So there's a service called AWS Glue, and AWS Glue helps you get the most out of the data that you have, and it helps give you that single source of truth of what lives in the data lake. So there are ETL capabilities, there's data crawling capabilities, and importantly, there's a data catalog that AWS Glue provides. That data catalog stores the data it stores metadata about what's in the data lake. So it gives a single version of truth to Amazon Athena users and Redshift users and EMR users, the fully managed Hadoop service. Even machine learning data scientists can look back to Glue to know what data is available to be able to perform their analytics. So we've brought to market something called a solution builder. And solution builders are templates, cloud formations that you can run inside of your account, and it builds you a reference architecture. So if you're totally new to building data lakes, you can go out to the Solution Builder website and click and launch these cloud formations to give you a reference architecture of a data lake in your account. If you like it, you can take that and expand it. If you want to customize it, you can do that as well because it's directly inside of your account. So we've just launched version 2, and hopefully this is something that's useful for you. So let's dive in a little bit to what data lakes on AWS look like. So of course you know Airbnb. Airbnb is a marketplace that brings together property owners and travelers. Now, Airbnb has grown significantly, and now there's 80 million guests staying at more than 2 million properties globally in more than 190 countries. Now, their VP of Engineering, Michael Curtis, he'll talk about how Airbnb is reinventing travel. And one of the ways they do it is through continuous innovation, making sure that they're focusing on things that are uniquely core to Airbnb and not spending their effort spinning up servers and doing patch maintenance and all the things that are the heavy lifting that aren't really part of the core Airbnb business. Now, their data has grown tremendously, and one of the challenges they have is to capture all that data. They're now growing by more than 3x or 300% every year. So what they've built for an architecture to handle this kind of volume of data and these analytics, they use S3 as their underlying data store. And they need to have a high-performance compute and a high-performance analytics layer, and they use HDFS. So using Amazon EMR, which is the fully managed Hadoop service, they're able to, whether they're running Hive queries or Spark queries or Presto queries, they can go back against that hot cluster for very high-performance analytics. However, they're managing tens of petabytes of data now, so they can't afford to put all of that data in a single Hadoop cluster. So they now have tiered storage where that data flows back into warm and cold data, flows back into S3. So let's talk about the first category, which are immersive customer experiences. National Australia Bank, or NAB, is one of the big 4 banks in Australia. And I was recently in Sydney and had a chance to listen to Patrick Wright, the Chief Technology and Operating Officer, as he was sharing the vision for how NAB is going to be providing for their customers great, connected, in-the-moment experiences. And they're doing this in a few ways. The first is they're going to be investing $1.5 billion over the next few years, including building a cloud guild where they start to insource those skills and capabilities that are going to be most important for NAB to build these experiences. The second is they're streamlining their operations so that for all of their customers, they're able to access and consume services in a much more easy and efficient way. And they're also starting to change their leadership and building better empowerment for their people. And one of the things that they're using as a core tenet is they want to leverage the cloud, they want to adopt microservices, and they want to embrace data better. So one of the services that they're launching as an example of streamlining that business is something called QuickBiz, and what they call in the moments that matter to businesses. An example of what a small business can do through QuickBiz, they can apply for a loan up to $100,000. And within 60 seconds, QuickBiz makes a determination if they get that loan or they don't. Now, the reason that it's so fast is that NAB has built machine learning on the back end to decide are they going to back that loan and grant that loan or not. So from an experience standpoint, now small businesses are able to come, ask to see, hey, do I qualify this loan, and immediately know if they do or they don't. And it's been so impactful that actually 30% of all the loans that are evaluated by NAB for small businesses are done using this platform. Now, another thing that they've launched is the NAB Discovery Cloud. The NAB Discovery Cloud is meant to provide exceptional hindsight, insight, and foresight for the bank. It is the foundational platform for machine learning, analytics, and their marketing ecosystem. Now, all these users may be using different analytics frameworks like Zeppelin or Jupyter or RStudio, but underneath the Discovery Cloud, as they import these banking sources and customer interactions, they land them into an S3 data lake They use Redshift, which is that fully managed AWS native cloud data warehouse. And they also are using EMR, so the fully managed Hadoop service. The reason that NAB decided to go with AWS is they needed to build a highly elastic data lake that allows for them to use almost anything and use it however they want and whenever they want. The second category is around a culture of experimentation. So I'll share with you Siemens. Now, you may know Siemens as a manufacturer of industrial equipment, but Siemens is really large. They are one of the leading automation providers, and they have 30 million automation systems, 75 million contracted smart meters, and over 800,000 connected products that are out in the field. Their goal is they wanted to use all that data that comes from these connected devices and do something a bit smarter, offer better analytic solutions out to their customers. So Steve Bashada, their EVP and their GM of product lifecycle management, said they wanted to choose AWS when they looked at all providers because AWS had the performance, scalability, and security that they needed to build a software as a service offering and to build a platform as a service for their ecosystem to build more applications. So Siemens was very excited that they were able to launch in January of this year MindSphere. So Siemens MindSphere version 3 is a closed loop path to engineering using over 40 AWS services. Now, what does that mean? Not only does MindSphere have a number of ingestion mechanisms to bring in data from Siemens devices and also from third-party devices, but they also have a development of platform layer where Siemens and other third parties can build applications for design and engineering, automation and operation, and maintenance and services. And inside of MindSphere, it's using S3 as their data lake, using Redshift for analytics, and RDS for their database automation. Now, when we talk about closed loop, they use something called a digital twin. If you're not from manufacturing, you may not know what that term means. Digital twins are very interesting. It's the ability to simulate a real-world environment in a digital space. So whether they are doing digital twins for product or production or performance, they're able to simulate what happens, say, on a factory floor directly in a virtual environment. So if they want to experiment, change how a machine is operating, or look at different sensor data and change some settings, they can see what the impact of that is without actually having to affect the physical environment. So a very exciting offering from Siemens in this space. And the third and the final category is around new business models. Now, new business models are the launching of new products and services. I'll share with you FINRA. Now, FINRA is the financial regulator of North America, and they're responsible for looking after about 99% of all equities exchanged, and about 60% of all options trades that are made. Now, as Steve Randich, the EVP and the CIO, has shared, they're a Wall Street regulator, and their job is to make sure the markets operate fairly and honestly, and there's no manipulation. So a really important job that they have. They have to manage a huge amount of data. They ingest about 75 billion events per day, and when they do analytics, they're talking about trillions of records that span over 20 petabytes of data. So really massive scale that they're operating at. The way that they've built their data lake is they, again, have S3 as the underlying storage layer, but they've built their own metadata store. So they've built something called Herd. And Herd allows all their analytics users, whether it's people who are running Spark or Presto or Hive, to be able to come down and access the data lake with that single version of the truth. It has opened the door for them to have better analytics around depth of market and interactive reports, investigations, order lifecycle, and also even the market space. So by being able to operate the way that they were before on-prem, moving it to a data lake on AWS and offering their analytics platform on AWS, they've been able to drop their cost profile by about 60%. But there's something else that they got out of this. It isn't just they operate at a lower cost profile, they've built a huge amount of competence in the analytics space. They now have dozens of companies that are approaching FINRA, big banks, other regulators, other financial services firms, are coming to them to learn from their experience. So FINRA has not just gotten good at analytics, they're actually selling consulting services now. On top of that, they've also built something called FINRA Automated Data Delivery System, or FINRA ADS, where now these entities can come in and get access to trade journals and tick size pilot firm review files. They can get trace security activity reports and so on. So As they've built more and more competence in the analytics space, they're now able to launch new products and innovate more in this space. So we've heard today about empowering builders, about innovation accelerators, and about transformative innovation. So with that, I'd like to welcome back Werner. And we put together a really packed schedule for you today. We've got 10 tracks and over 50 sessions. And we hope that these are really useful for you. So with that,
now go build.
Thank you.